Welcome back guys, you are watching Unicode Education. In this session, we'll be learning about algorithm and flowchart. By the end of this video, you will know what an algorithm actually means and also the uses of flowchart. So before starting, if you have not watched our first session, please go through it so that you will come to know about the introduction of C programming as well as the history and features of C programming which has made it so popular. So coming to this video, if you have still not subscribed our channel, if you are a new visitor, subscribe our channel now so that you will get notifications of the new videos we upload in the same course as well as others. So starting with it, so we are learning the basics of C programming, and the basics are algorithm and flowchart. So coming to algorithm, what an algorithm actually means. You might have heard your seniors talk about algo like that. It's a short form. Algorithm is also called algo. So just definitions are not important, only for engineering students. If they get any question about define algorithm, you must write this definition, that's it. But I'll just explain it briefly. So step by step procedure, the first definition I am solving here, step by step procedure to solve a problem. So here three things you should note: one, computer word, then solve a problem, then step by step. So if you remember these three sequences, you can just tell the definition: step by step procedure to solve a problem using computer, that's it. You need to solve a problem using computer. So what are the procedure, what is the step by step procedure, that's it. That's what called an algorithm. I'll be explaining brief in the next slides, but here just the definition I am explaining, don't worry. So next one, definition 2. What's definition 2? The same definition 1, they have changed the words like that's what you just remember like that. But here a new word is added. What's that word? In computer science, a sequence of unambiguous. What does unambiguous mean here? So unambiguous means unambiguous, just pronunciation. 100% it's right. It's going to be right. It's correct, like that. It just means it's correct 100%. You are sure that those steps will give you the result what you need. The problem, the solution to the problem will be 100% right, like that. Unambiguous. Ambiguous means you are not sure, like that. So I hope I'm unambiguous meaning you have understood. So in computer science, a sequence of unambiguous steps to solve a problem is called algorithm. That's it. Okay, I hope definitions have clearly noted it down. You can also take a screenshot now. So moving to the next slide. Here I have explained the properties of algorithm. What are the properties of algorithm? So first of all, coming to it, it's finiteness. An algorithm must always terminate after a finite number of steps. See, for example, you have a problem. What is, you have A which is equal to 1 and B which is equal to 9. So you need to add those, the sum of A and B. What you will do, A plus B, you will give it as C and print C. So what will be the answer? It will be around 10. Okay. Next, here what you should note is that you should not just write it like this. Then this will happen, then this is the step. You should add start before the start of the program and stop in the end of the program. So only if you write stop, then it means it's an algorithm, because algorithm is always having finite number of steps and it should terminate after some steps. It should terminate, then only the problem will be solved, or else the problem will be going on like that. So I hope you understood what is start and stop. That also will be explained in the further slides, but here just note it down. Any algorithm will start with start and then stop with stop. You should mention that. Okay, so I'll erase it off here. We'll just take it down. Yeah, now you got to know what finiteness is. Then definiteness. What do you mean by define? Define means just shut your mouth and agree to what they say. I mean, if they have defined A is always equal to 1, just shut your mouth and agree, accept that A is always equal to 1. That's the meaning of definiteness, if we say in a funny way. But here the definition you should know a bit to explain if any question comes for engineering students, properties of algorithm. So definiteness, each step of an algorithm must be precisely defined. What step you are taking, how you are taking it should be precisely defined. The actions to be carried out must be rigorously and unambiguously specified for each case. So if you specify like that, the program will shut its mouth and carry out what you have defined, like that. Unambiguous means it should be 100% correct. It should give the required result. Okay, so each step of an algorithm must be precisely defined. It should be correctly defined. That's called an algorithm. So finiteness over, definiteness over. Next comes input. In input, I'll erase it away. Yeah, In input, an algorithm has 0 or more inputs. So an algorithm, there is no any hard and fast rule that algorithm should have inputs like that, must have, nothing like that. It can have 0 or more inputs. It's as per the problem statement. For example, if the problem statement is to check the temperature, the algorithm can take an input of what is the temperature, like that. Like that it can take, and it can give you, it can suggest you clothes, like that. So that is quantities which are given to it initially before the algorithm begins. So algorithm, you'll just mention first. What do you mention? Start, you will mention first. You will say start, right? After start, it should take all the input, whatever input it's required. For example, in a clothes suggesting any program, like I told, it will ask the user what's the temperature outside. So you will enter before the program starts. I mean, after the starting, it should be entered, so that the program can take it as an input and process the results as per the input given. So inputs can be 0 or more inputs. That remember, just that's required. Okay. Then output. An algorithm has one or more outputs. So here there is no 0 output, because if you have a problem, if you are putting an algorithm, there will be a problem. It's 100% right that without a problem you can just not frame any algorithm. After the problem, the algorithm is framed just to give a solution. If there is no solution, it's not at all called an algorithm. So output should have one, at least one, but input can be 0, but output should be 1. That you should note. I'll put it in some another color. Yeah, sorry. So this is so important, that's why I am taking so much time here. Yeah, in a red pen, if I take, input can have 0 inputs, but an algorithm should have one output, at least one output. That you remember, one or more, here 0 or more. Okay, that you got to know. Now, effectiveness. An algorithm is also generally expected to be effective. It should be effective, or else it's not an algorithm, because unambiguous steps actually already defined. This means that all of the operations to be performed in the algorithm must be sufficiently basic that they can be done in principle exactly and in a finite length of time. It should not take infinite length of time. Then you can't just give any software like that. You can just think about it. If it's infinite, there is no meaning in putting that algorithm. So I hope properties of algorithm is clear. Just take a screenshot if you need. So moving on to the next slide. Here we'll be looking towards the examples of algorithm. I just explained what is an algorithm and properties of algorithm. Here you'll get to know everything. What is an algorithm? How is it framed, like that? So coming to the definition, what was the definition? Step-by-step procedure to solve a problem using computer. So here you can see the steps. I hope it's visible. So algorithm for adding any two numbers. Already I told, I was talking about adding any two numbers. How will you write an algorithm? For example, you may get a question, write an algorithm for adding any two numbers. Then what will you do? Start with step 1. Just write start. You should write that for everything. Then you are taking in values. Input the two numbers to be added and assign them to variables x and y. So first you started, then x and y has been input, it has been taken. Then compute values z, such as z is equal to x plus y. Next you are calculating x plus y, which you will be taking as z. Then display the value of z. Then you have to display the value of z. Then you should stop the algorithm must stop here and start to stop. You should write total. If you don't write start and stop, it may cost you marks as per the teacher. So I think you have understood this. You start it here, and then x and y is taken as input, then x plus y it's added, then z is displayed, and the program stops. So this was example 1. Such examples we'll see. So the second example, algorithm for checking a given number is positive or negative. Assume 0 is positive. So any number is given to the program, it should give us if it's positive or negative. Okay. Here they have also given a condition. Assume 0 is positive, because 0 can't be taken as negative and positive. Just assume that it's positive. So step 1, you are starting. I've already mentioned start and stop is there, so you can see here. Then step 2, input the number and assign it to variable x. So you started, then taken down the number, input the number as x, check if x is less than 0, then display the given number is negative, otherwise display the number is positive. That's it. If and else, it will come in the future, but just for algorithm, just check it. It will check here, then it will report if it's positive or negative, then it will stop. Okay, this is an algorithm for checking a given number is positive or negative. Why are algorithms used? You may be wondering about it. So here you can see you'll get a complete structure of the program. You can just taking the input, then if and else tags can be used. Like that you can get an idea. That's why algorithm means it's a set of instructions. So there are many types of algorithms, many long lengthy pages of algorithms are there that you can learn, but just now you can just understand what algorithm is. So I hope understood. And it's a continued version of algorithm. What is pseudocode? Code means the real code. Pseudo means it's not truth, like that. It is an informal way of programming description that does not require any strict programming language syntax. It is used for creating an outline or a rough draft of a program. So for example, I'll write here it's pseudocode, and here it's the normal code. Okay, just take it. You in the normal code, you are taking x is equal to 1 and y is equal to 2, c is equal to x plus y, print c. This is as per Python. So this is the Python code here. But in pseudocode, what will you do for this? You will just say, like you can just, actually I've added it in a slide also. Yeah, here for adding two numbers, this you got to know. I hope this one coded version. Here pseudocode sample, the same sample here we are taking. So you can write it like this: what is the procedure and what the end product. So the procedure is we are adding number x and number y, and taking it to z, the value is putting it to z, and then we are displaying z. That is the procedure. And the end product, what are we doing is add. This is like a pseudocode, how we frame pseudocodes. So pseudocodes and algorithms will help you create a picture of the program before even coding it. Before even starting to code, you will get an idea of what to do. Like you will get a clear statement, like we are taking input here, then if else tag will be taken, like that you will get an idea. That's what called pseudocode and algorithms. I hope you have understood everything. So now we'll move on to flowchart. What exactly is a flowchart? So flowcharts you might have seen in science, in maths too, and literally all subjects use flowchart in these days because they are easy to remember. That you just easy to visualize. That's why flowcharts are used in coding too. What are they? Why are they used? We'll see. Before the definition, pictorial representation of an algorithm. Algorithm you can write it down, but to see, to have a picture of it, you will do, what we'll do is just create a flow chart of it. We'll just create a flow chart. It represents the flow of execution of instructions in an algorithm by computer using graphical notations. So here we will use graphical notation such as square, rectangle, or like this, or a circle, and arrows we'll use to just represent any algorithm. So that I'll explain in the next slides. You can see here we have those. Coming to definition, the third point I'll tell you. So need to study various symbols or pictures used to represent an algorithm as flowchart. So you have to study the symbols, so that the symbols, just like plus symbol denotes positive and minus symbol denotes negative, here the rectangle denotes different, this denotes input output, like that. Different things are there. I'll explain it in the next slides. So I think flowchart you have understood. Just take a screenshot if required. So advantages, first of all we'll talk about advantages, so that you will be curious to study the what symbols mean what, like that. So advantages: effective communication. So flowcharts are better way of communicating the logic of system. You can understand by yourself why it's effective. So effective analysis, that's also you can understand because you are getting graphical image. Just like see, if you watch films on TV, you will understand it, right? You'll understand it. You can analyze it, you can communicate it. Even if your friend asks in any middle scene also, you can just say, oh, that happened. But if you're reading books, if you are studying, that won't happen because you are visualizing in TV, but here you are just reading it like that. So that is the importance of flowcharts. So easy debugging and efficient testing. So debugging, you might know what debugging is. If you don't know, so there will be errors in code. Any human will make mistakes, so there will be some mistakes in code, typo errors, like that errors will be there. To clear the error, to correct the error, it's known as debugging. The errors are called bugs. Here I am writing bugs. Errors are called bugs. Okay, I hope you understand. So easy debugging and efficient testing. So testing purpose also it will be useful. Okay, how it will be useful you'll know in the coming section. So next, efficient coding. The flowcharts are very useful during program development phase. So if you create a flowchart while coding, it will give you a graphical representation so that you can just analyze it through your eyes, and that will help you code in a better way. Next, proper documentation. While writing documentations, flowchart serves as a good program documentation which is needed for various purpose. So documentation will be helpful for efficient testing, debugging, and for new users who are using your program. They should know what your program does, how your program works, like that. That's called documentation. Documentation will contain all the readme files. Readme files are known as documentation. All program details will be in the documentation except the secret things, like what hash you have used, how security have you provided. That doesn't be added in the documentation, but everything else which the user needs to use that program will be added. So next, efficient program maintenance. Maintenance of operating programs becomes easy with the help of flowchart. So for maintenance also, like debugging, testing, maintenance means if you want to upgrade anything, if you have created a calculator and if you want to upgrade a feature of using trigonometric ratios, then also it will be useful, so that you can just cut off the flowchart at that point and add the, like this. If the flowchart is there, you can cut off this part like this and add trigonometric ratios like this, like that, just like that. It will be helpful. So advantages you have come to know, just take a screenshot if you know. So next, what are the notations used in flowchart? So this is important. So any program, any software developer will know all this, and it's important just because even if anyone, it's universal. If anyone writes it, he will do it in the same way. If anyone forms a flowchart, he will do it in the same way. So start or stop will be like this. Just remember, I can't explain. It's like an ellipse. Then input or output will be in this symbol. Subroutines means while tags. If you want to carry out a process until any until I is lesser than 5, you should print hello world, like that. If it's there, it's called subroutine. Until some given condition is met, that program should run. That's called subroutine. Okay, that just remember. Then process or calculation, the sum or subtraction, like that. Any process is going on means if the string is getting split, like that, the process, just remember the process is like this and the decision is like this. Connectors, arrow keys, like just if you use start here and stop here, this arrow key is a connector. That's just a thing. So notations you have understood, I hope. You can just take a screenshot, it's so important. Just keep it in the screenshots, your gallery, so that it will be helpful for you. Yeah, so notations you have understood. Now we'll look through some flowcharts. Yeah, this also you can, notations used in flowchart in books they will use like this. Beginning will be used like this, like start is also called beginning here. So beginning they have used, and stop is known as ending. So ending you can use it like this. See, just observe the arrow key here. Here arrow key is pointing downwards, here to downwards, but into the module, into ending. But here it's starting, so it's common sense, you can understand that. So then input output operations, I had already told, it will be like this. Input output means you are taking in the data via scanf as per your C scanf, and you are outputting it with printf, like that. Okay, that's called input and output. The library used is st standard input output library. Okay, what happened? This is the library used. Just remember stdio.h. It's it's always used in C programs, that's why. So now processing already I told, and condition statements. So what I told you, actually always some condition is there. For example, if else, if temperature, why is this happening? Yeah. If temperature T is greater than 25, tell them that it's hot. Just like that I'm taking, don't take it in a serious way. Else, if it's else, tell them that it's cold. That's it. So here temperature will be checked in this condition. If it's false, it will say cold. It is, if it's true, this T is greater than 25, here he can continue like that. This is the notation used for conditional statement. It can be also branched like this. So what does this, you can just think about it. What does this say? Just comment it in the comment section below. You can just use your common sense. If I keep on telling everything, then it will be like just boring for you and you'll skip this away. So that just put it in the comment section. If you understood this, then you have got all the points in the flowchart and you can be a pro in programming. Okay, flow line, connector, here table. Yeah, I'll exit through this so that you can just take a screenshot of it. Yeah, I hope it's visible. Take a screenshot so that it will be helpful for you. Yeah, now moving forward, flowchart for addition of two numbers. We have seen the algorithm for addition of two numbers. In the same way, we'll see here the flowchart for two numbers. So first it's starting here, then stopping here. That's important. Beginning or ending you can write, or start or stop you can write. It must be written so that it means any algorithm should terminate. So you are saying it's an algorithm here. So then you are taking A and B as input here. So A and B as input here. So sum is another variable. So here you are adding A plus B and taking that value and putting it to sum. Okay, then output the given numbers A and B and the computed sum. So here you are outputting A is 1, B is 5 for example. So the sum comes out to be 6. Like this you will just write. So it has displayed. Now the algorithm has come to an end. We have met our solution. The problem is to add and we have given a solution. So that's what algorithm needs, and we have represented it graphically. Pictorially we have represented it. So next you are calculating simple interest. Okay, I will show you the algorithm. You can just practice the flowchart if required. It's not so important, but if you practice now, you will just start getting interest in it and you can just do great things. So here for simple interest, you can remember the formula. Simple interest I is equal to P, principal time rate, by 100. That's it, right? You just need to know the formula, then you can same like summing, adding the sums. So start stop is there already. So we are taking input P, R and T. PTR, if we know, we can calculate I. So that PTR we are taking as input and we are calculating it via this formula here I have shown. Then we'll display the simple interest, then stop. That's it. So in the flowchart also the same happens. See, you can just see this is input output we are taking as input. So this is output. So this is again input output. In the same way they have been done. They have been represented in the same way. So this is the process. So every rectangle is a process. Then this is the start and this is the stop, beginning and the end. So this is a flowchart. So area of a triangle, you can just say they used Heron's formula here. So this is the area of a triangle. You can just pause the video and go through it so that you can get all the information in here. Input output, again processes, these are input outputs, start and end. Okay, so next comes out to be largest of two numbers. There are two numbers, you should just print the largest, output the largest number. So here what you will do, just you can thus I will explain it so that since it's a bit complex for you since you are beginning. So first start and stop over, then you are taking A and B as input. So here conditional statements I have already told. Is A greater than or equal to B? If A is greater than equal to B, means if it's true, then output A is larger. If A is greater than B, it's larger, so output A as larger. Or else if it's not true, if it's false, then output B as larger, then stop. So you understood, I hope. This here is the algorithm. This one is the algorithm and this one is the flow chart. Okay, so this is the largest of two numbers. Then check if a number is positive or negative or zero. So this one you can work out by yourself. Don't see the flowchart, I already shown what to. Just work out by yourself, frame the what's so called the algorithm by yourself and the flowchart by yourself, and just analyze it how far you have done correctly. So it will help you out in the future. So practice makes man perfect, but always it doesn't make you perfect. If you keep on practicing ABCD, then you will be sitting in the ABCD level only. But you just need to explore different things. You should practice by yourself so that you will be a pro in programmer too. Sum of first in positive numbers algorithm is given and flowchart is given. You can also work it out. Such examples I am giving, you can just note it down and work it out. Sum of first in positive numbers flowchart. Okay, you can also send your worked out pics on our Unicota Insta. I'll show you the Insta ID here at underscore UNIQUOTA underscore. You'll see our logo, you can just decide it. So just go to Unicota Instagram and you can just post your, you can just DM me with your working out pics so that I can help you out. Also we can publish your photos on our Instagram account. So factorial of given number, you can work it out. You just know what a factorial means. 3 factorial is equal to, you'll be knowing, but if you are not in 11th, if you're still in 10th and all, you'll just 3 into 2 into 1. In the same way, if x factorial is given, x into, sorry, what's happening here? In the same way, if x factorial is given, what's the answer? X into x minus 1, like that, factorial, x minus 2, x minus 3, just until it becomes 1. That's why here they have taken prod 1. This you remember, and just work it out by yourself so that you will get a correct idea. So I've shown you some examples of flowcharts as well as algorithm. This video has been really helpful for you because you might not notice it now, but while you start coding by yourself, while you start programming, it will be really a great thing for you to learn about what algorithm and flowcharts are, so that it will ease your coding journey. So thank you guys, thank you for watching this video first of all, and even if any of your friend is interested, please take your time to share them our video so that it will be helpful for them too. If you're still not subscribed to our channel now, and also like this video so that we will get encouragement to do more such content for you. So thank you guys, thank you for watching this video. Take care in the next video. Bye-bye.